And again, we have a new problem that indicates something. We need to use the conservation of charge here. And the problem is three concentric spheres with radii r, or I guess here 2r and 3r in vacuum. Okay. The inner sphere has a charge q, the middle sphere is uncharged, and the outer sphere is grounded. Its potential is equal to 0. The middle and the inner sphere are connected by a conductor. Okay. Oh, so this was the conductor. I thought it was a mistake to draw something like that, but this is the conductor. Okay, fine. And what is the amount of charge that will pass through the conductor? Oh, after the system comes to equilibrium, we already know that the Earth's potential is equal to 0. And let the charge on the inner sphere is Q1 changed because it has been connected. So its initial charge of course was equal to Q, but the charge on it must change since it is connected to something foreign, some other thing, some other conductor. So its charge is going to change. And after those connections, the inner surface have charge Q, I just suppose, and Q2 on the middle one. And according to the principle of conservation of charge, that Q1 plus Q2 must be equal to Q. This was the principle of conservation of charge so far. And I can write and I can assume the charge on outer sphere is Q3 because it is also connected to something else, and it is in an external electric field, and it is connected to Earth, so it will have some its share of charges. I assume this is equal to Q3. So the potential of the outer sphere, which is J0, can be written as phi 3, and that will be equal to 1 upon 4 pi epsilon naught. And Q1, Q2 and Q3 all are supposed to at its center, so I can write it simply as Q1 plus Q2 plus Q3 upon its radius 3r, and that is equal to 0. And that explains something, that we should write Q1 plus Q2 plus Q3. We should write it equal to 0. And that means Q3 is equal to minus Q1 plus Q2. And that means this is equal to minus Q. So the potential of inner and middle spheres, and also the potential of middle and inner spheres, are equal. So we can write the potential of inner sphere as phi 1, and that will be 1 by 4 pi epsilon naught. The planning is same for Q1. Its potential is Q1 by R. For Q2, its potential is Q2 by 2R, and for Q3 its potential is Q3 by 3R. So phi 1 is simply 1 by 4 pi epsilon naught Q1 upon R plus Q2 upon 2R plus Q3 upon 3R. And phi 2, the potential of the middle sphere, it is 1 by 4 pi epsilon naught, and then we can see the picture and write down it. This sphere, this is Q1 by 2R plus Q2 by 2R plus Q3 by 3R, and I can write it Q1 by 2R plus Q2 by 2R plus Q3 by 3R, and both are equal. And phi1 is equal to phi2, and you can calculate things. And delta q, what is delta q? We will get, you can find the value of q1 and q2. q3 is already q1 and q2, and q3 is already calculated. It is equal to minus q, and I earlier got q1 is equal to q upon 6 and q2 is equal to q upon 2. I have calculated, you can calculate as well. And the charge that passes through the wire is q. Initially the charge was q. This is q minus q1, and then because q1 rested on the inner sphere, it has already got some charge q, and q1 rested on the inner sphere, so q minus q1 is the charge that flown through the wire. So delta q is going to be q minus q1, and if q1 is q by 6, so its value you can get from here, and it has gone to charge q2, perhaps charge on the middle sphere, and q2 is q by 2. So I think there is something missing in this calculation. It might be the answer of something else, and perhaps q1 must be equal to q by 2 and q2 must be equal to q by 2. So the answer must be q by 2. You can check it. I haven't checked it, but from the conditions I can know that if q3 is equal to q, if q2 is equal to q by 2, then q1 must be equal to q by 2. And that's all. Thank you very much for watching.